All right. Let's look at if you have a specific amount of a substance and you know a reaction that it will undergo, how can you calculate the amount of heat that will be produced or absorbed for that specific amount of substance to react, or what will happen when that specific amount of substance reacts? So what we're given is the reaction of iron metal with oxygen and air leads to the production of iron oxide, trioxide. This forms the basis of a hot pack used by athletes to warm tired muscles after exercise. How much heating can be provided by a hot pack that contains 0.1 pounds of iron metal? Assume that no other energy transfer occurs. So, what we need to do is we are given a reaction equation which tells us what is the relationship between the amount of iron, so the amount of iron and the amount of heat that is produced when so much iron reacts. Okay, so that's essentially what we're given. Now we're told only only a smaller amount of iron is actually reacting, hence that's going to change the amount of heat that is produced. Okay, so our first step is we're given the mass of iron. We can't really relate anything with the mass of iron. We need to relate that to number of moles. But we're also given it in pounds. So we first need to convert those pounds to grams. So let's start there. We want to calculate the mass of iron in grams. So currently we have 0.100, and I struggle to write this unit so that it looks proper, so I'm going to call it large LB. It's not really what it is, it's small LB, but so that you can actually see what I'm doing. And we're also told that there are 454 grams in 1 pound. Right, so you know how when you're given an equation like that, it means the thing on the right, it can be divided by the left, that gives you its ratio. So that's how much we have. So that's about 45 gram, 45.4 gram. So you can calculate that. So not necessarily from that we can then get the number of moles. So the number of mole of iron is going to be equal to the mass of the iron divided by the molar mass of the iron. And the molar mass of iron is 55.85 gram per mole. Okay, that then gives us 0.8130 mole iron. Okay, so now we know how much iron we actually have, and we need to find a way to relate that to the reaction equation. So what does the reaction equation always tell us? In terms of enthalpy, it tells us that 2 mole of iron per mole of the reaction is related to minus 824.2 kilojoule per mole of the reaction. There doesn't need to be a minus 1 there. Okay, so that is the given information. It tells us 2 is equal to minus 824.2. Now we have 0.8, so how much is that equal to? So the basic thing that you can write, so you can say therefore the energy transfer is equal to the amount of iron and remember a chemical equation gives us the ratio. So it tells us that there is 2 mole of iron would give minus 824.2 kilojoules. So you see, technically what I do is I substitute that, and I do the same thing as what I did with the pounds. I say the thing at the right is divided by the left. And what's common between those two? The thing about mole reaction. So it's so many kilojoules per 2 mole of iron, and then you can just calculate it. You get minus 335 kilojoule. Three significant figures. What does it tell us? It tells us 0.8 mole of iron will produce minus 335 kilojoule, which means it gives off 335 kilojoule of heat for 0.8 mole of iron. The reaction equation tells us 2 mole of iron would have given off 824.2 kilojoule of heat. So maybe this is an easier way of seeing that whole thing. You can also write this ratio as the units I wrote up there, so kilojoule per mole reaction. So if you write, there's 824.2 kilojoule per mole reaction, and there are 2 mole of iron per mole reaction. You see the units still cancel because that and that will cancel with each other, and the mole iron will cancel with the thing that stands over there, and you're still left with kilojoule. Okay. The third method of relating those numbers is you say 2 mole of iron needs to relate to minus 824.2 kilojoule per mole reaction. Then it is 2 mole iron per mole reaction. Right, because you're right, but the units up there. Then you say, but we have 0.8130 mole, I'll just leave that, mole iron. Why not mole iron per mole reaction? Because it's just a quantity. It's just a quantity. So you just write mole iron, and then that means we're calculating delta H, not delta RH, we're just calculating delta H. Cross multiply, you'll see the mole reactions cancel, and you're going to be left with minus 335 kilojoule. So importantly, when you're working with enthalpy, you write the stoichiometric unit, so 2 mole iron Fe, so it's 2 Fe to delta RH naught, and you use the units of mole reaction here. But the actual quantity of iron only has units of mole iron. So then you'll see you'll end up with a specific amount of delta H in kilojoule. Okay, I hope this gives you some confidence. So you see there's 3 ways that you can get the units right, or at least calculate the energy transfer for this situation. All right, I'll see you in the next